Hello, my name is Sahar Hassan, and I'm the Applications Engineer with LMK Technologies. I'm here to talk to you about LMK's innovative gasket sealing technology used for mitigating infiltration in wastewater collection systems. LMK was founded in 1993 by President Larry Kice Jr., and for the past 20 years, LMK has pioneered research and development of technology for renewing and sealing lateral service pipes in wastewater collection systems. Cured-in-place pipe, or CIPP as it is better known, has been used for structurally renewing pipes since the early 1980s. However, one of the little-known facts about CIPP is that while it enhances the structural integrity of the system, it does not necessarily make the system watertight or leak-free. Resins used during the process of CIPP shrink as they cure, thus leaving an annular space between the liner and the host pipe. Water is easily able to track in this annular space and re-enter the collection system at manhole and lateral connections. Thus, while the wastewater collection system is structurally enhanced, it is still plagued by infiltration. This is LMK's hydrostatic test tank, used for testing CIPP main to lateral connection liners. The hydrostatic test tank can perform non-destructive testing of various kinds of liners and resin systems. This video demonstrates the testing of a one-piece structural liner system with two types of resin systems with and without a connection gasket being installed. Test 1 involves the use of a one-piece structural connection liner with a silicate resin system without a gasket being installed at the connection. Gaskets were only used at the terminal ends of the mainline liner to prevent water from leaking at those points. Once the tank was filled with water and pressurized, water was observed to be leaking through the connection. A close-up shot of the connection shows us the water tracking behind the liner and re-entering the system at the connection. The first test just demonstrated using the hydrostatic test tank involved the use of a one-piece main-to-lateral connection liner without any compression gasket seals installed at the main-to-lateral connection, the upper end of the lateral liner, or the terminal end of the mainline liner. Due to the absence of the compression gasket seals, water was easily able to track between the liner and the host pipe and re-enter the collection system. Test 2 involves the use of a one-piece structural connection liner with a polyester resin system and a compression gasket seal at the connection. The tank is filled with water and pressurized. When the seals come in contact with water, they expand and fill the annular space between the liner and the hose pipe. As demonstrated by the time-lapse video, over a period of 36 hours, infiltration is completely eliminated from the system. The main-to-lateral connection of this system is now not only structurally enhanced, it is also watertight. The second test just demonstrated using the hydrostatic test tank involved the use of a one-piece main-to-lateral connection liner with compression gasket seals installed at the main-to-lateral connection, the upper end of the lateral liner, as well as the terminal ends of the mainline liner. These compression gasket seals expanded when subjected to water and effectively sealed out any infiltration from re-entering the collection system. To summarize the two tests just demonstrated using the hydrostatic test tank, Test 1 used a silicate resin system, which is known for its low shrinkage properties, along with a structural one-piece connection liner and no compression gasket installed at the connection. When the tank was filled with water and pressurized, water was observed to be leaking from the connection. Test 2, on the other hand, used a polyester resin system, which is known for its high shrinkage properties, along with a structural one-piece connection liner and a compression gasket installed at the connection. When the tank was filled with water and pressurized, the compression gasket expanded to seal the annular space and over a period of 36 hours completely eliminated the infiltration from the system. These tests conclusively prove that irrespective of the resin system being used with CIPP technology, if the goal of the project is to rehabilitate the system structurally as well as to eliminate infiltration, it is important that gasket sealing technology be used in conjunction with CIPP.